Hopefully my markers will hold out. This is brand new. It's never been used till this very moment. Okay, P, R, Q. Some of you who are figuring these things out, one thing, you might wonder why we can't just take not Q and pull a P out of this thing. Because have you noticed how the rule of disjunctive syllogism, Bob, Maggie, tells us that we have to have the left side negated? Have you noticed that? But logically it shouldn't matter. If I have P or Q and I don't have Q, then of course I would have P.
You could just
Right, the new rule of commutativity makes us flip it around, but it's kind of a redundant rule. If it wasn't for Apley, I would just remove that requirement, but Apley makes you do it, so.
It's kind of, it can be a two-edged sword, but if you do too many at once, it's like an algebra, you can make a mistake.
Yeah.
It's better to do it more systematically than.
That is the argument for forcing one to do it that way. Okay. These are our first four rules. Modus ponens, modus tollens, disjunctive syllogism, and hypothetical syllogism. The antecedent is this part, the consequent is this part. So in this statement, everybody knows that this says if P then Q? Everybody, at least we're there, right? Okay. The part that follows the if is the antecedent, the part that follows the then is the consequent. So when we're doing modus ponens, what we're saying is if you have the antecedent of a conditional statement, then you can derive its consequent. In this statement, the antecedent's P. So if I have P, then I know that I'll have Q. So this says if P then Q, I do have a P, therefore I have a Q. We could put words in there. If I study my logic, then I'll pass the class. I studied my logic, therefore I passed the class. Modus tollens tells us if we have the negation of the consequent, that we can derive the negation of the antecedent. If P then Q, not Q, therefore not P. So let's use the same example before. If I study logic, then I'll pass the class. I did not pass the class. Therefore, we know I did not study my logic. Disjunctive syllogism. Notice that of these four rules, this is the only one with a different main operator. The main operator here is conditional, the main operator here is a conditional, the main operators here and here are both conditionals. In disjunctive syllogism, we have a disjunct, hence the name disjunctive syllogism. Okay? This way I have P or I have Q. If I don't have P, then that leaves me with Q. Everybody with me? So if you come to my house and I say, you're like, hey, Kingard, you got anything to drink? I'm like, I got beer or wine. And then you're like, well, you don't have any beer. Well, then if I wasn't lying about this, then I must have wine. And when we're looking at these things, we assume that this is true. We assume that it's true that I have P or Q. Now remember, if it says I have P or Q, what it means is I have at least one of them. I may have both, but I have at least one. So if I come to find out I don't have one of them, then I must have the other one. So if I have P or Q and it turns out I don't have P, then I must have Q. Hypothetical syllogism tells us that if the consequent of one conditional is the antecedent of another conditional, then the antecedent of the original conditional can be used to derive the consequent of the second conditional. I know that's a mouthful, but one way to think about it is just if I study, then I'll pass the class. If I pass the class, then I graduate. Therefore, if I study, then we know I'm going to graduate. So now then, the next step that you've got to realize is that these are basically just, in essence, they're theorems of some sort, where the P could be anything. So let's look at it this way. Imagine my first premise is T and X. If T and X, then S. I have T and X, therefore S. All right, this is what a problem might look like in one of your homework assignments. And so then the idea is you have to show that using these premises alone, you can get to this conclusion using the rules. If you can show that you can get to this conclusion with these premises using the rules that you have, then you'll have proven that the argument's valid. What I'm trying to display here is that this T and X, notice it's a more compound statement than the way we see it over here in modus ponens. But that P could be anything and so could that Q. So in this case, one way to think about this is to think about this T and X is represented, in essence, represents this P. You with me? And this S represents this Q. So since we If we look at it over here, if P then Q, if I study then I pass, I studied, therefore I pass, make the same move here, whatever T and X is. Let's say it's study and you practice your proofs. If you study and practice your proofs, then you will succeed. You studied and practiced your proofs. Therefore, what does that mean? You succeed. So if you were solving this problem on line 3, you would write S. And then you would tell me how you got it. What lines did you use? What rule did you use? In this case, we used line 1 and 2. What rule did we use? Modus ponens, as we signify MP. So what we're looking at here is a completed proof. You'd be done. You would have shown that this argument's valid. Anytime that you write down a line, you need to put down how you got it. How did you derive that particular component? Which lines did you use? What rule did you use? A little rule of thumb that'll help you. Every single one of the rules of implication, which is your first 8 rules, takes 2 lines except for 2 of them. Simplification and addition will only use 1 line. We haven't got those over here yet because they're in the next 4. Simplification and addition, which we'll talk about momentarily, use 1 line. All the rest of the rules will always use 2 lines. So if you find yourself tempted to write down 3 lines, you're making a mistake. When you look at it in this simple form, it all seems straightforward, but then you start seeing these big equations and all of a sudden you're like, whoa, man, I can't figure out what's going on here. It's all about main operators. It's all about main operators. If you can identify your main operator, then you can figure out which rules you can apply. So for instance, at 7.1, we only have these 4 rules. So if you don't have a conditional statement in your premises, you should know immediately that you're going to be using this. Now once we get more rules, you won't be able to necessarily do that, but at this stage you can rule things out pretty easily. But it's all about recognizing the main operator. So let's say I have this. Out of these 4 rules, how many of them can I use on this? Just 1. DS is the only one I can use. What's my main operator on line 1, Barbara?
The wedge.
That's right, the disjunct. Well, since that's the only rule that I have that even functions with a disjunct at this stage, we know that we're going to be using that. Now imagine I do this. Hang on. I'm not going to get ink on myself. Are you lost?
No, it's now.
That's right. Now it's modus ponens. Rachel, what's my main operator on line 1? That's right, my conditional. What's the consequent of line 1, Christian?
L.
That's correct. What's the antecedent of line 1, Maggie?
Brackets, if P then Q and P and S, that's the end.
Say it again?
The whole,
Yeah, but can you read it to me?
yes. If P then Q or T and S.
That's right. So if I have P implies Q or T and S, then I can get L. So if, for instance, you solve this problem on your book, it says you have to get L using these premises, you would, on line 3, write L, and you would put down the 2 lines that you used and the rule that you used. We're going to use line 1 and 2 and the rule modus ponens. So you can see it's all about identifying the main operator. That thing's huge. There's a conditional, there's a disjunct, there's a conjunct, but none of that matters because the main operator is a conditional. So the only rules we can apply to it are rules that would be able to use conditionals. In this case, it happens to be modus ponens that's going on.